than yesterday to make the notes a little better. So, graphing rational functions. This is day 4 of Unit 3, block day. Graphing rational functions. Okay, I think you did this last year a little bit, but it seems like there was a variety of ways it was taught, maybe depending on teacher so I'm not exactly sure, but I'll just teach it from scratch and pretend that you've never seen anything like this before in your life. That's a bit of an exaggeration, but I'll teach it from scratch, and we'll see what happens. All right, in this section we'll examine rational functions with the idea of getting information from them so we can sketch the graph. Okay, big picture, these are long problems with lots of pieces to them. The good news is we will always prompt you for the pieces. Now the end goal is the graph, but we'll always ask you for each piece individually. So it's not like I'm ever going to say, hey, there's the equation, graph it, without asking you all the in-between steps. So you don't have to remember all the steps of what you need to find. Like, you need to know how to do all the steps, but we'll prompt you each time for all the little pieces. And so your job is to fill in the 1, 2, 3, 4, 5, 6, 7 pieces of information, put all that stuff on the graph, and see if you've got enough information to go from there. So, long problems, putting together a lot of what you hopefully already knew. All right, super important that you factor first. And I guess it goes without saying, if you factor it wrong, then the rest of the problem is going to be wrong, and it's really a pain to try to figure out how many points you get once you factored wrong and then did the rest of the stuff right. So, all that's to say, let's make sure we're factoring correctly. I'm not really worried about that with you guys, but everybody makes a mistake once in a while. Having said that, we'll see if Avery and Marcus can avoid making a mistake on the first factoring. Avery, how about the numerator?
It would be 4x and 10x plus 2.
Good. 4x and x plus 2. Marcus?
X plus 2 and x minus 12.
Good. Oh, I noticed something already. Don't cross them out yet. We're going to get to that in a moment. But yes, they do both have an x plus 2. Okay, find the domain of f. Well, domain is denominators and square roots. Well, there's no square roots to worry about. So the only thing I'm thinking about is the denominator can't be 0. Can't have a denominator of 0. So I look at my denominator, x can't be negative 2, and x can't be 5. And that's good enough for like the format of that, the notation of that. You don't need to write that in integral notation because it takes a while. It's kind of messy. No, the point is x can't be negative 2, x can't be 5. All right, question B. Does the graph of f have any holes? So do you remember I don't remember who was taught or know who was taught what. Do you know if the graph has holes? Some of you are shaking your head. Where is there a hole, and how do you know? What x value is there a hole at? Negative 2. Because holes come from factors that cancel. Holes come from factors that cancel. So that's the x value of the hole, but I'd really like to know the y value as well so that I can put it on my graph and help graph this thing. By the way, once you account for the hole, then you can work with the reduced polynomial or the reduced fraction from here on out and don't have to worry about that x plus 2 anymore. All right, so how do I find the y coordinate of the hole? Plug it in. Make sure you plug it into the reduced form, right? Because if you plug it into the not reduced form, you're going to get 0 over 0. That's the whole point, that there's a hole there. So plug it into what's left. Negative 8 over negative 7. So 8/7. Little side note, you know that in math class a lot of times we rig the problem so that you get decent answers. Less so in pre-AP classes, but even still, most of the time they're sort of rigged to work out so that you don't have terrible answers. We can't really do that on these problems because there's so many pieces. It's hard to make everything work out nicely. So a lot is going to work out nicely, right? They both factored. A bunch of the stuff's going to have integer answers, but it's really hard to make everything work out nice. So if you get a couple of weird answers, you're probably fine. If you're getting like all weird answers, then you probably did something wrong somewhere. Part C. Does the graph of f have any vertical asymptotes? Do you know what you're looking for vertical asymptotes?
Greater degree of the denominator.
You're thinking that's horizontal stuff. When you're thinking degrees of top versus bottom. So you're thinking right, and we'll get there in a moment.
The top and the bottom.
That's the top no, bottom O equal co stuff. But that's for horizontal. So yes, you're on the right track, but not vertical asymptotes. Vertical asymptotes are factors of the bottom that don't cancel. Factors of the bottom that don't cancel. Right? So even the order of the questions that we ask you, there's a reason for the order. So you take care of the holes. Once those or that is gone, then we're looking at factors of the bottom. We've already took care of the canceled ones. So x equals 5 is our vertical asymptote. Right? These three questions are always go together. I mean, not just because they're always the first three questions, but they always go together because they are related to each other. Namely, every domain issue is either a hole or a vertical asymptote. So everything you write down as a domain issue is either a hole or a vertical asymptote. So those first three questions are all very much related to each other. Question D. Does the graph of f have any horizontal asymptotes? Okay. So some of you are familiar with top no, bottom O equal co. I kind of don't like that, and the reason is when you get to calculus, people start using it when they're not supposed to use it. So if you're familiar with it and you want to use it, go for it. I'm not really going to approach it that way, but it's not wrong. So if you use it and use it correctly, that's fine. It's just a lot of times students remember that rhyme, and they remember the rhyme so well that they just like using it everywhere. Like some of you almost did it for vertical asymptotes. And in calculus, it's even worse of a problem. There's more places that people are like, oh, top no, bottom O equal co. Like, well, yeah, your rhyme is right, but not here. So if you want to use that, that's fine, but it's only good for horizontal asymptotes, not anything else. A more math teachery way to remember it is that horizontal asymptotes, and we'll tie it together in a moment, but horizontal asymptotes happen as x goes to infinity. Right, as x gets really, really big, or maybe really, really small on the other end. And when that happens, we're thinking about, again, I'm going to use the reduced because I don't have to worry about the original anymore. So when x goes to infinity, I can use the biggest term. No, let's call it the lead term, because lead term means the one with the highest degree. Use the lead term in the bottom and the top and see what happens. Again, lead term meaning highest degree term. So the highest degree term in the top is 4x. The highest degree term in the bottom is just x. And that equals 4. So y equals 4. This was an equal co problem for you guys that want to use that. Equal meaning which degree is bigger. So which has the bigger degree? If the bigger degree is in the top, then there's not a horizontal asymptote. If the bigger degree is in the bottom, then the asymptote is 0. And if the degrees are equal, like 1 and 1, like this problem, then you use the coefficients. So, again, I'm okay if you use top no, bottom O equal co, but please use it correctly. Again, the problem with it is not that it's implemented wrong, it's that it's used in the wrong places. Does the graph of f have any slant asymptotes? Okay, if it's a top no problem, then it's a slant problem. And so this one's no, it does not, because it had a horizontal. Another way to say that is graphs have either a slant or horizontal asymptote, not both. So the top no is sort of a top slant. That doesn't rhyme as well, so we just still say top no, bottom O equal co. But a better, again, it doesn't rhyme, but top slant, bottom O equal co. All right, so these two questions kind of go together because you always answer one or the other, but never both. So the answer to one of those is always no. All right, y-intercepts. Now we're getting back to our middle school math stuff. Y-intercept is where x equals 0. So let's plug 0 in for x. Over negative 5 is 0. So 0, 0 is my y-intercept. The x-intercepts happen when y is 0. So we plug 0 in for y. And then what makes a fraction be 0? The top being 0 or the bottom being 0? The top. We already handled, if the bottom is 0, that's either a vertical asymptote or a hole. So we already took care of that. If the top is 0, that's what makes a fraction 0. Right, way back when, 0, okay and no, you remember that? You ever shown that? If 0 is in the top, that's okay, you get 0 for an answer. If 0 is in the bottom, that's a no. That's sort of the domain question. 0 in the top is the x-intercept question. So where the zeros are, very important. So 0 would make the top 0, that makes the fraction 0. So 0, 0 is also our x-intercept. All right. 13 minutes later, we have all of our information. Obviously, this will go much faster once you kind of got the hang of it. Now we go back. We're not done yet. Now it's like we're halfway through. Now we're going to go back and take all of those things we wrote down, put them on the graph, and see if we can figure out what the graph looks like. Okay, so just start over at the top. X can't be negative 2, x can't be 5. Okay, well, that doesn't really show up on the graph until I get to part B and C. There's a hole at negative 2, 8/7. So negative 2, 8/7. And do your best with 8/7, right? It's a little more than 1. It's less than 1.5. That's about as good as we can get for a graph. Part C says we have a vertical asymptote at x equals 5. So I'm going to go to x equals 5. And put my vertical asymptote on there. I don't really need to label it, but I'm trying to keep track of things. Question D told me there was a horizontal asymptote at y equals 4. So we'll go to y equals 4. Put us a horizontal asymptote there. No slant asymptote. Y-intercept and x-intercept are both 0, 0. So I can put a dot there. All right, now if you've done some of these, which I think you have, you remember sort of their basic shape. So you combine your sort of background knowledge with the points we have, with the asymptotes we have, and I think that's enough to sketch in at least the left part of the branch. And then I need you to show at least 1 point per branch. Show at least 1 point per branch. So this one we automatically got 2, so we're good with that side. But I need something on the other side. And if you need extra points, you just go with the old-fashioned table of values, pick some x that's over in the region you want, and see what you get. Before we get there, let's see if we can guess or figure out, do we think this is going to be like below that horizontal asymptote or above the horizontal asymptote? Do you know? You're right, it's above. Do you know why it's above? Okay, so it feels like they're normally like across from each other or catty corner or diagonal.
Isn't it just origin symmetry?
So it doesn't have origin symmetry because there's the origin. But you're right, it does have sort of symmetry with this. That's not the origin, but symmetry with the asymptote intersection. I don't know, that's never a mathy thing, but you're on the right track with that, yes. Another reason it's not down here is if it was below, then we would have another x-intercept. We don't have any more x-intercepts, so like this is, I can't cross that line anymore, so it must be above. Even if you can't figure out where it is, that's not going to matter because I got to plug in a point anyway. So that's at 5, so I need to plug in 6 or 7 or 8 or 9 or 10. You get to pick. Based on this graph, it looks like 6 is going to be way off the page, so I'm going to go with 7. You could go with 6. I'm going to do 7. You could do both. So 4 times 7 over 7 minus 5. Right, 4 times 7 over 7 minus 5. 28 over 2. 14. I'm still off the graph, but at least I'm not as off the graph. So 7 comma 14. So that's roughly up there. Again, you only need 1 per branch. So if you're good with that, then fine, go with it. If you're thinking, I'm not sure, that's off the graph, what does this look like? Then maybe try a different point, or try another point. So I'm going to try 10. Again, only need 1, but if you're nervous, then you can try multiple and see what happens. Running out of space here. If I plug in 10, I get 40 divided by 5, which is 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I'll just roughly sketch in that other branch. So that one problem took us 20 minutes. Now, granted, we were learning and going slow, so they won't all take 20 minutes, but it does illustrate that there's a lot of pieces to these problems. All right, let's try to speed up a little bit on number 2. First thing we want to do, though, is factor. It's a good way to take roll and find the people who dropped and still have their popsicle sticks. So, Danny, how about factor the top for us?
2x plus 2.
2 and x plus 2. David, how about factor the bottom? Good. X minus 3, x plus 2. Again, I see that there's a hole there, but don't do that until you get to the prompt for it, because it might mess up other questions. Okay, I'd like to group my questions ahead of time, because I know domain, holes, vertical asymptotes all go together. Horizontal and slant goes together, and then the intercepts. Okay, so domain. LaSalle, what can't x be?
3 and -2.
Okay, good. And that means that those are either holes or vertical asymptotes. Blake, do we have any holes?
Yes.
Yes. What's the x value of the hole?
-2.
And then what do I do to get the y value?
Plug it in.
Plug it in. Plug it into what's left. 2 over x minus 3. So 2 over -2 minus 3. -2/5. So that's not great, but oh well. Who's still here and who's not? Grace, how about any vertical asymptotes? So, yeah, let's say x equals 3. X minus 3 is the factor we're looking at, but that means x equals 3 is the vertical asymptote. By the way, some people like to start their graph and, like, as they get information, start putting it on the graph. That's completely okay. I usually like to find all the information and then put it all on the graph. If you want to hop back and forth, you're certainly welcome to. All right, horizontal asymptotes or slant asymptote. Okay, I'm going to do it the mathy way first, and then we'll talk about the shortcut way again. So horizontal asymptotes, that means as x goes to infinity, so as x gets really, really big, 2 divided by really, really big is going to what? If you have $2 in your pocket and you want to divide it evenly among everyone on Earth, about how much money does everyone get? 0. Doesn't ever equal 0, but that's the point of an asymptote, right? It doesn't ever really get there, but it gets closer and closer to 0. Again, top no, bottom O, so this is the bottom O category here, because it's bigger on bottom, equal co. Again, use the little saying if you like, but make sure you only use it where you're supposed to use it. If there's a horizontal, there's not a slant. So do write no there, right? Don't just leave it blank, because then I'll think you're not sure. So go ahead and say that the answer is no. Y-intercept means x equals 0. So we'll plug in 0 for x. 2 over 0 minus 3. That gets me -2/3. X-intercepts, that's where y equals 0. So 0 in for y. So 0 equals 2 over x minus 3. Okay, we can times both sides by x minus 3. And if I do that, I get 0 equals 2, which is not true. So no, so this thing does not have an x-intercept, and it's very much related to the fact, Tanner, what did you say?
The horizontal asymptote.
There's a horizontal asymptote at y equals 0. Now, be careful, you can cross a horizontal asymptote. So just because there's a horizontal asymptote doesn't mean you don't cross it. You can cross a horizontal. Can't cross a vertical. That's a domain issue. You can cross a horizontal. We don't this time, but be careful on that one. All right, we got all our information. Now it's time to work back through and see if we can put it all on the graph.
I have a question real quick. Do you want me to come up there?
Yeah, come up here. So why don't you start putting all that information on? I'll press pause and I'll put some on too. All right, so when I put everything I know on the graph, I've got 2 points on the left branch, which is twice as many as I need. And you combine that with asymptotes and sort of your basic former knowledge of how these things look. That's probably enough for you to sketch in that branch of things. Do we think the other side is above or below? Above. But we have to have a point anyway, so let's table of values. I'm going to try, this one looks to be a little closer in, so I'm going to try x equals 4 and see if I hope I get something nice. If not, so be it. 2 over 4 minus 3, so 2 over 1 is 2. So 4 comma 2. So yes, it was above like we thought it was. If you want to do more points, you certainly can, but I'm feeling comfortable about how these things look, so I'll go with my 1 point and go with that. Again, if things are looking weird, then it probably is wise to check multiple points and see how things are going. Because everything's supposed to fit together. When you put it all on the graph, if something looks out of place, then you probably did something wrong. Like sometimes students, if they put the hole, if it ends up here, like, wait a minute, that doesn't fit with my graph. So there's kind of a built-in check. And the good news is the more information you have, the more sort of built-in checks you have, that it should all fit together. Number 3. By the way, the first one took 20 minutes, that one took 7 minutes, right? So we're speeding up here. Not because we're intentionally just trying to go fast, just we're getting better. Let's see. Who else is here that we could pick on today? Madison can factor the top for us. And Jess can factor the bottom for us. Well, Madison, I'll give you a moment to think about it then. Jess, factor the bottom for us. Thank you.
X minus 4 times x minus 1.
X minus 4 and x minus 1. Madison, multiple numbers that multiply to negative 20 and add to negative 1. X minus 5 and x plus 4. Yes. Good. We don't have something that cancels, although if we factored that wrong we might. But we don't. We factored it right. Nothing cancels. Hayden, how about the domain?
X can't equal 4, x can't equal 1.
X can't equal 4 and x can't equal 1. Which means those two things are either holes or vertical asymptotes. Maybe one of each. Who knows? Alex, do we have any holes?
Holes. X value, I think I need is 1.
Holes come from factors that cancel.
4. Negative 4.
Well, the top's x plus 4, the bottom's x minus 4. So there aren't any holes. Those don't cancel, so no holes. Well, sort of process of elimination, Cameron. Do we have any vertical asymptotes? Yes, you can.
X equals 1, x equals 4.
Good. X equals 1 and x equals 4. And that was a good question. Can you have 2? Because we hadn't had 2 yet. But yes, you can have 2. You could have as many factors as you had in the denominator. You could have that many vertical asymptotes. I doubt we're going to give you more than 2, but obviously we could give you a factored form, as many as we wanted to give you down there. All right, horizontal asymptotes. Hesitant to call on anybody because I don't know which method you're going to use. So somebody tell me, what do we think? Does it have a horizontal or a slant? I think you're outvoted. It has a horizontal. Is it top no, bottom O, or equal co? equal co, because they're both x squared. Again, the more mathy way is, well, if x is going to infinity, what matters most is the biggest term, so x squared and x squared, but that would reduce to 1, which, hey, is the coefficients. So yes, equal co, which means we don't have a slant asymptote, right? Those two questions go together. There's always one or the other, but not both. And back to Cameron's question, you will only have one horizontal asymptote. So you can have multiple vertical, but only one horizontal. That sort of makes sense. As you go out to infinity, the graph can't be approaching two different things. That wouldn't make sense. But you could have multiple vertical asymptotes. All right, y-intercept means we set x equal to 0. You can set x equal to 0 in the original or in the factored form. You should get the same thing either way. But if we're plugging in 0, it's probably easier to do it in the original. Although, I don't know, not a whole lot easier, because negative 5 times 4 is negative 20 over positive 4. So 0, negative 5 for my y-intercept. For my x-intercept, we set y equal to 0. And hey, it's already factored, so this should be an easy thing to handle here. What makes a fraction 0, the top or the bottom? The top. So what values of x make the top 0? 5 and negative 4. Let's write those as an ordered pair, though. 5, 0, and negative 4, 0. All right, we got lots of information on this one. Let's see, x equals 1 and x equals 4. For our vertical asymptotes. Y equals 1 for our horizontal asymptote. And then y-intercept 0, negative 5. X-intercept of 5, 0 and negative 4, 0. Alright, so this graph has like 3 regions to it rather than just 2 because of those vertical asymptotes. Those vertical asymptotes cut it into 3 pieces here. The leftmost piece I feel good about because I got 2 points over there. They're both already kind of close to the asymptote. So I feel pretty good about what the left side looks like. I really don't know what's going on in the middle because I don't have any points. I know I don't have any x-intercepts in there, so it can't be anything below. It'd have to be up above. We'll come back to that. On the right-hand side, I got 1 point that's already like tucked in close to the asymptotes, so I know what that's going to look like. So what do I do to figure out where the rest of the middle portion is? Plug in 2. You might have a guess, you might be right, but you got to have a point in there anyway. So let's plug in 2. Plugging in 2. Factored form or non-factored form. I don't know which is easier. I'm going to go factored form. Negative 3 times 6 over negative 2 times 2 minus 1 is 1. Well, at least I get a decent answer anyway. Negative 18 over negative 2 is 9. Okay. So it's above, but I kind of knew that already. I think I want to plug in 3 because I don't really know what else this thing is doing. And that's kind of the, fallback position on any of these. If you get stuck, just start plugging in points. It's not the most efficient way because you don't want to plug in 20 points to get everything. But if you need an extra point, plug it in and see what happens. 3 minus 5 is negative 2. 3 plus 4 is 7. 3 minus 4 is negative 1. 3 minus 1 is 2. So the 2's cancel, the negatives cancel, and I get 7. Well, how helpful is that? I don't know, but I can't cross the x-axis. You guys mentioned before about the flip thing. It does usually flip when you cross a vertical axis. So if this side's going down, then this side's going up. And if this side's going down, then this side's going up. So it's got to do something like that. The only time it doesn't flip across a vertical asymptote, it has something in common with what we did the last couple days. It doesn't flip if it's a double root, right, because it bounces. It doesn't flip if it's a double asymptote. So if you had x minus 1 squared down there, we wouldn't change across x equals 1. I mean, obviously that would change a whole bunch of other stuff too. But if you got a double asymptote, it won't change across that asymptote. Number 4. Okay, this is a piece of a problem rather than a whole problem. Find the equation of the slant asymptote. All right, top no, bottom O equal co. Well, top no means top is a slant. If it's bigger on top, it's a slant. And if it's a slant, you have to divide. So top no sounds the easiest, right? The answer is just no. Well, it's no for horizontal asymptote. That's what the thing tells us. The little saying tells us about horizontal asymptotes. But if it's not a horizontal, it's a slant, and you have to divide. So, am I synthetic division eligible here? No. So x cubed plus 0x squared minus x minus 6 divided by x squared minus 2. So this goes back a couple weeks. Something times x squared gets me x cubed. Well, that would be x. X cubed. X times negative 2 is negative 2x. Draw the line, change the signs. I get x minus 6. What times x squared gets me to x? Nothing. So what is this x minus 6? What did we call that? That's the remainder. The good news is, for this section, the remainder is useless. It doesn't do anything for us. I mean, that's bold to say that of the remainder. Hope his feelings aren't hurt. But the remainder doesn't matter. We take what's in the top, and the top is our slant asymptote. So it's after you divide, it's your answer, throw away the remainder. That's the slant asymptote. Number 5. In behavior, that's a fancy word for asking for horizontal or slant asymptote, right? Because in behavior means x goes to infinity. Well, some of this is easy, or they gave us I can throw that out. There's a hole at 3. It doesn't ask me about that, but I can cancel it out. I know that means there's a hole there. Is this top no, bottom O equal co? Is it a horizontal or a slant? It's going to be a slant, which means I have to divide This is kind of annoying. What do I have to do before I divide?
Factor.
It's already factored. I need to multiply it back out. It's like, yeah, come on. I thought they were being kind by factoring it for me, only for me to have to multiply it back out. Oh, but how is this problem better than the last one? I can synthetic divide. So 2, 2, negative 12, 0. What number am I going to put out front? Negative 2. So copy down the 2, multiply, add, multiply, add, multiply, add. I don't get 0 at the end, but I was not expecting to get 0 at the end, right? Because 0 at the end would mean it's a factor, but clearly it's not a factor. So I already knew it wasn't a factor, but now I proved it. That's the remainder. We just throw that away today. And what's left is 2x squared minus 2x minus 8. That's my slant asymptote. And really it's a parabolic asymptote. So that's kind of weird. It's going to approach that parabola. You're not going to have to graph them where they approach a parabola. So I can ask you that question, but I'm not going to put that on a graphing problem, because then you have to graph the parabola only to let it be like the asymptotic parabola, which is weird to think about. So yes, that's what happens. No, we're not going to graph it. I want to get to the quiz, but we can... Let's do part of number 6, not all of number 6. Yes, sir.
Will the end behavior of a rational function always be the same as its slant or horizontal asymptote?
Will the end behavior always be a slant or a horizontal asymptote? Yes. Yes, because your options are top no, bottom O, or equal co. Again, bottom O, equal co, those are the horizontals. Top no is the ugly situation where you got to divide.
So if we're saying that our slant asymptote is 2x squared minus 2x minus 8, then the rational function that came from will have the same end behavior as that parabola?
Correct. So when you get away from the the vertical asymptotes and the weird stuff in the middle, when you get out toward the ends, it's going to be approaching this parabola. And if we had time, we could graph it on a calculator. We could graph this parabola and graph this thing and see that, yeah, in the middle this is doing weird stuff, but at the ends, this is going to approach that. And you're curious, so you're going to do it. Let's look at number 6. I don't want to do all of number 6. I do want to do some of number 6. Fernando, can you factor the top for us?
X plus 2 and x minus 1.
I almost pulled a popsicle stick for someone to factor the bottom. That would have been a great popsicle stick to get for the day. Okay, so domain, well, I'm going to breeze through this. X can't be negative 1. There's not any holes. There's a vertical asymptote at x equals negative 1. All right, so once you get the hang of these, you can breeze through some of this stuff pretty quickly. What are we looking at here in terms of top no, bottom O equal co? Top no. In fact, if you want to use the saying, it's like you need to put the top no with the slant, because if it's top no, that means it's a slant. It's no to horizontal, but that means it is a slant. Copy down the 1, multiply, add. And at this point, it kind of doesn't matter. When you start to realize the remainder doesn't matter, then I'm kind of done, because I'm just throwing it away anyway. So my slant asymptote is y equals x. And we go from there. Y-intercept would be x equals 0. So 0, negative 2. X-intercepts are where y equals 0. Those are the things that make the top 0. So that would be negative 2 and 1. So y equals x already put on there. X equals negative 1. 0, negative 2. Negative 2, 0. And 1, 0. Okay, I mentioned earlier that when you have complicated ones like this, you get lots of information, which feels like a lot of work. But when you get to the graph, it's good news because you got a lot of information. So on the right-hand side, I've got everything I need. I've got 2 points. And on the left-hand side, I've got everything I need. I only have 1 point, but that's all I need. If you wanted to plug in negative 3 or 4 or 5 to see that it got closer, you certainly could. But that's 1 point is all that's needed. All right, worksheet 4 is today's assignment. Due tomorrow is not worksheet 4, because that'd be a really quick turnaround. It is worksheets 1 through 3.